All right, guys, section 2.9, logarithmic expressions. So, before we get into problems involving logs and how we're going to use them, I want to take a second and really talk about why logs are useful. So everybody in this course was introduced to logs in Algebra 2, but they're kind of viewed as this random thing that isn't very useful. It's not very real world. So I just want to establish a couple things first. One reason that logs are useful is they can help us express large numbers in a more manageable form. All right, so sometimes when you have exponential data, if you plot it on a graph and you count everything like, by tens or ones or whatever, but like increasing by the same amount each time on this axis, your graph will look like this. It's flat almost the entire time, and then it rapidly accelerates and goes almost straight up. So that can make it difficult for people to kind of wrap their head around whatever data this is representing. And so one thing that logs help us to do is kind of smooth this out. All right, so we're actually going to look at this at the end of Unit 2. We're going to look at what do we do with data if we have a graph like this? How do we make it not look so like, taking such a long time before it finally kind of turns the corner and goes straight up? So that's one use of logs. The other use would be really in science courses and engineering, computer science as well. Logs kind of help solve real world type problems. Now we're not going to get to this in this course because it's not a science course, it's not an engineering course. But know that like in future courses, this will be useful in science as well as in engineering. All right, so that's why logs are useful. Let's talk about what they are for a second. So logs are simply a different way to write exponential equations. All right, so if we have an exponential equation that's written like this, we can write it in an equivalent form as a log. And to do that, you just write the word log. The base of the exponent becomes the base of the log. And it's kind of like these two things just switch places. Okay, so the C goes to the left, the A goes to the right, or you can think of it like this. The A and the B were together, now they're on opposite sides, right? And the C was on opposite side, now it's with B. All right, so this is simply a different way to write this. They actually mean the same thing though. All right, so let's take that and look at some questions here. All right, so we're gonna convert each of these. I've got 6 questions. I know they're cut off at the bottom, but I'll move it in a second. So convert each of these either from exponential form to log form or vice versa, log form to exponential form. All right, so first question. We've got a log, and we just want to write this as an exponent. So to switch from log form to exponential form, we're going to get rid of the word log. The base of the log becomes the base of the exponent. And remember the other two things, it's sort of like they switch sides, or we're switching what is with the 3. So the x was with the 3, now the 4 is going to be with the 3, and the x goes to the other side. All right, so that's our answer to the first one right there. Yes, we could evaluate 3 to the 4th, but we're just writing this as an exponent and we're stopping. All right, so that's number 1. Number 2, the natural log of 3x equals 2. Anytime you have a natural log of anything, I'll put x, this is just a log with a base of e. Right, so the natural log is a log with a base of e. So to convert this to an exponent, remember the base always stays the base. So the base of e is also the base of our exponent. The 3x was with the e, that's going to jump to the other side. And the 2 was not with e, now it's going to be on this side in the exponent right there. All right, that's number 2. Now, number 3. So, some people find it easier if the log is on the left side of the equal sign. So if you want to just rearrange this, you could do that. You could just move the 2 over. I'm going to leave it as is to do this one, but again, you could swap the order of this. All right, so number 3. We've got a log without a base. So if it actually spells the word log without a base, that's a base of 10. All right, the previous one said the natural log, or ln, that has a base of e. If it spells the word log without a base, it's a base of 10. All right, so converting this to exponential form. 10 was the base of the log, it's still the base of the exponent. Now, because the log's on the right, I'm not gonna necessarily switch the sides of these two, but what was with the 10 is not going to be with the 10 anymore. It's on the opposite side of the equal sign. All right, so writing this as an exponent, the 2 was not with the base, now it's going to be in the exponent like that. All right, so that's log form, and then that would be our exponential form right there. All right, 3 more for this on this slide, and one more slide after that. But number 4, we've got 3 to the x equals 4. All right, so this is an exponential form. We're going to write it as a log. So the first step, and I know this is obvious, but you have to write log. I have people or students that sometimes skip that step and they get completely lost. So first step is you write log. The base of the exponent becomes the base of the log. And again, these two things, it's like they're going to switch sides. Whatever was with the 3 is going to be on the opposite side of the equal sign. So the x is going to move over here, and the 4 is now going to be with the 3, right there. All right, so that is our log form on number 4. Now, number 5. Same thing. So some people find it easier if the exponent is on the left. So if you want to, you can just move the equals 4 over here. I'm going to leave it, but again, you might find it easier if you move that 4 over to this side. All right, so converting to log form, so we're going to write log. And this log is going to have a base of e, because that was the base of the exponent. So the base becomes the base. But a log with the base of e, we don't call it log base e, we call it ln, or the natural log. So ln. Now, I'm going to put that e there just temporarily, just to kind of help us. But I'm going to erase that in a little bit because it doesn't need to be here when it's a natural log. So what goes after that? Well, whatever was not with e before is now going to be with e. And so 4 is going to be over here. And then equals, and what was with e is now on the opposite side of e. So negative 3x would go over there. All right, so, and again, the e, I just put it there to help us. But this is how we would write it right here. All right, that's the log form of that exponent. Now, number 6, 10 to the x equals 8. All right, so we've got a log. We're going to write this in log form, rather. Our base is going to be the same as that base right there. So a base of 10 is still a base of 10. And then what was with the 10 jumps to the other side. And what was not with the 10 is now with the 10 on the left-hand side of the equal sign. All right, so this is the log form. It wouldn't actually be written with the base of 10 though, because remember, a log without a base is the same thing as a log with the base of 10. All right, so this is more likely how it would be written on like a multiple choice test. All right, up next. So we're going to evaluate some of these logs, but without a calculator. All right, we will do some practice with the calculator in class using Desmos, but this is just going to be strictly without a calculator. So the way that we evaluate logs without a calculator is we have to convert this into an exponent. The issue, if we go back a couple slides here, is there's no equal sign. So to go from log form to exponential form, we need an equal sign. So we have to add that in. All right, so log base 4 of 16, we have to set it equal to something. I'm going to call that something x. All right, but again, to evaluate logs, we have to set it equal to something. Now, to get it out of log form, we're going to convert this to an exponent. So as an exponent, this would say 4 to the x equals 16. Well, now and most of the time it's going to be pretty straightforward what to do here. We would just think through, well, what exponent does this have to be to make these two sides equal to each other? Well, if I square 4, if I multiply it by itself, that would give us 16, so x is just 2. By extension, log base 4 of 16, we can now say that is just equal to 2. All right, number 8, log base 3 of 1/9. Again, to evaluate this without a calculator, we have to set it equal to something, so we're going to call that thing x, and then convert it into exponent form. So as an exponent, 3 is still the base. These two things, again, basically switch sides. So 3 to the x equals 1/9. And this one's a little more difficult because how do we get from a whole number to a fraction? And so you might remember one of our previous lessons was if we had something to a negative exponent, that it would equal this right here. And so that's what's going to happen here. To turn the 3 into a 9, it's going to have to be to the second. But to turn the 3 into a fraction, it's going to have to be a negative exponent. And in this case, it would be -2. The second way to think about that is to rewrite 9 as 3 squared. All right, and then get rid of the 3 in the bottom by making it have a negative exponent. And if we did that, let's see, this would just say 3 to the x equals 3 to the negative-2nd. All right, so what does our exponent have to be? Well, it has to be -2, and so that's our answer to number 8, -2. All right, number 9, which is actually going to be a lot easier than number 8. Again, we've got a log without a base, so it's a base of 10, and so we're trying to figure out what does this equal. Right? So we've got to set it equal to x, and then convert this into exponential form. So as an exponent, again, the base is 10. These two things are going to switch. So x is now the exponent, and 10 jumps to the other side. Well, what would x have to be for these two things to be equal? Well, we don't even want x to be there, so we're just going to make it a 1. Right? 10 to the first is 10. And in fact, that would be true anytime those two numbers are the same. So if you've got a log with a base of b, and then this number is also a b, that is always going to equal 1, right? Because b to the first is going to equal. All right, so I know that's a lot. Again, we're going to practice this a lot in class. We're going to spend a good amount of time with logs. But that'll be it for this one, guys. Stay flawless.